An amiable welcome to everyone. This is your Lecdem channel to enhance your understanding. Our department videos will be available in the playlist. You can check it. Today, we are going to see about micturition. Micturition is a process by which urine is voided from the urinary bladder, and it is a reflex process. In grown-up children and adults, it can be controlled voluntarily to some extent. Functional anatomy of urinary bladder and urethra. Urinary bladder is triangular hollow organ located in lower abdomen, and it is formed by smooth muscle. It consists of three ill-defined layers of muscle fiber called detrusor muscle, that is, inner longitudinal layer, middle circular layer, and outer longitudinal layer. In empty bladder, many folds called rugae. At posterior surface of bladder wall, there is triangular area called trigone. At upper angles of trigone, two ureters enters the bladder. Lower part of the bladder is narrow and forms the neck, and it opens into urethra. Male urethra has both urinary function and reproductive function. Female urethra has only urinary function and it carries only urine. Male urethra is about 20 cm long. Throughout its length, the urethra has mucus gland called glands of Litter. Male urethra is divided into three parts: prostatic urethra, membranous urethra, spongy urethra. Next, female urethra is narrow and shorter than male, about 3.5 to 4 cm long. After origin from bladder, it travels through urogenital diaphragm. Urethral sphincters. Two urethral sphincters in urinary tract. Internal and external urethral sphincters. Internal urethral sphincters. It is situated between neck of the bladder and upper end of urethra, and it is made up of smooth muscle formed by detrusor muscle. This sphincter closes the urethra when bladder is empty. External urethral sphincters. It is located in urogenital diaphragm, made up of circular skeletal muscle fibers and innervated by somatic nerve fiber. We will see about the functions of nerves which supply the bladder and sphincters. Process of filling the urinary bladder. Urine is continuously formed by nephron and it flows into urinary bladder through ureters. When urine collects in the pelvis of ureter, the contraction sets up in pelvis. This contraction is transmitted through rest of the ureter in the form of peristaltic wave to urinary bladder. Peristaltic wave usually travels at a velocity of 3 cm per second and develops a frequency of 1 to 5 per minute. The peristaltic wave moves the urine into the bladder. After leaving the kidney, the direction of ureter is initially downward and outward. It turns horizontally before entering the bladder. At the entrance of ureter into urinary bladder, a valvular arrangement is present. The position of ureter and valvular arrangement at the end of the ureter prevents the backflow of urine from bladder into the ureter when the detrusor muscle contracts. Thus, urine is collected in bladder drop by drop. A reasonable volume of urine can be stored in urinary bladder without any discomfort and without much increase in pressure inside the bladder, that is, intravesical pressure. It is due to the adaptation of detrusor muscle. This can be explained by cystometrogram. Micturition reflex is the reflex by which micturition occurs. This reflex is stimulation of stretch receptors which is situated on the wall of the urinary bladder and urethra. When 300 to 400 ml of urine is collected in the bladder, intravesical pressure increases. This stretches the wall of the bladder, resulting in stimulation of cis receptors and generating the sensory impulses. Pathway for micturition reflex. Sensory impulses from the receptors reach the sacral segment of spinal cord through the sensory fibers of pelvic nerve. Motor impulses produced in spinal cord travel through motor fiber of pelvic nerve towards bladder and internal sphincters. Motor impulses cause contraction of detrusor muscle and relaxation of internal sphincters so that urine enters the urethra from the bladder. Once urine enters urethra, the stretched receptors in the urethra are stimulated and send afferent impulses to spinal cord through pelvic nerve fibers. Now, the impulses generated from spinal centers inhibit the pudendal nerve. So, external sphincter relaxes and micturition occurs. Once the micturition reflex begins, it is a self-generative. That is, initial contraction of bladder further activates receptors to cause further increase in sensory impulse from bladder and urethra. These impulses in turn cause further increase in reflex contraction of bladder. The cycle continuously repeatedly until the force of contraction of bladder reach maximum and the urine is voided out completely. During micturition, the flow of urine is facilitated by the increase in the abdominal pressure due to voluntary contraction of abdominal muscle. Higher centers for micturition. Spinal centers for micturition are present in sacral and lumbar segments, but these spinal centers are regulated by higher centers. The higher centers which control micturition by two types, inhibitory centers and facilitatory centers. Inhibitory centers for micturition. Centers in midbrain and cerebral cortex inhibit the micturition by suppressing spinal micturition centers. Facilitated centers for micturition. Centers in pons facilitate micturition through spinal centers. Some centers in cerebral cortex also facilitate micturition. Here we can see the process of how the urine is filled in urinary bladder and it is voided. The summary of this topic is functions of urinary bladder, urethra, male urethra, female urethra, urethral sphincters, functions of nerve supplying the bladder, filling of urinary bladder and micturition reflex. Thank you.